We are starting the webinar now. Good evening to all members who have joined today to this webinar. Respected senior INS members and friends, it gives me a great pleasure to welcome you all to this 14th webinar series talk. As you are aware, INS webinar talks are given by eminent persons with remarkable achievements and accomplishments. Today we have with us Dr. Dinesh Srivastava, Chief Executive of NFC. He is going to talk to us on NFC, a Center for Development and Processing of Nuclear Fuels and Advanced Material for Nuclear and Strategic Application. Oh, this is truly a very challenging assignment of the department. Truly, it is a very challenging assignment of this department. As the final product in the form of a bundle or a pressure tube reaches our power plant from NFC, the entire program depends on the achievements of NFC. So people who have seen NFC in the last 10 years will appreciate the immaculate chain of activities performed with high precision that meets world standard. Our power plants are regularly breaking new records of continuous operation with every year passing. I believe NFC has a big role in this achievement. And on behalf of INS, I welcome you, sir, and wish you an accomplished professional career. Now, I request Sri Mehta to give his opening remark. Sir, you have to unmute yourself. Sir, unmute yourself.
Sir, you are muted.
Can I hear you?
Yeah, now you are here.
Now you are okay.
Welcome, Dr. Srivastava. The NFC has been playing a very key role in providing all the inputs and components of nuclear power plants and various other special materials and other things that come there. It has been my privilege to be associated with the NFC from the very beginning, all the things that come. I was really keen to listen to the latest achievements and how the problem that you have faced and how the challenges you have overcome and how the Atmanirbhar you have made us on the program. So you are welcome again. Thank you very much.
Yeah. So before I invite Dinesh Srivastava to make his presentation, I have to introduce him to the audience. So Dr. Dinesh Srivastava, the distinguished scientist and chief executive of NFC, is a metallurgical engineer from University of Roorkee. He joined the 28th batch of PRC Training School, Mumbai in 1984. Subsequently, he was posted in BARC, Mumbai and served in various capacities for more than 3 decades. He obtained his doctorate degree from Indian Institute of Science, Bangalore. Dr. Srivastava has contributed exclusively in the development of advanced structural materials of extreme strategic value for nuclear energy program in India. He has published more than 200 research papers. Dr. Srivastava has been a recipient of many honors and several prestigious awards, including Binani Gold Medal, National Metallurgist Day Award from the Indian Institute of Metals, DAE Excellence Award, Homi Jahangir Bhabha Science and Technology Award, and Vasvik Award for Science and Technology. Srivastava is a fellow of Indian Nuclear Academy of Engineers. So I think there are more things to read out, but then let's welcome Dr. Dinesh Srivastava to give his presentation. And it is our great fortune to listen to him on our INS webinar. Dr. Dinesh Srivastava, I again welcome you and I request you to give your presentation. Thank you.
Thank you, Dr. Ramarao, and it's my pleasure. And thank you very much for introducing me to this August community of Indian Nuclear Society, to all my seniors, and I wish to thank Dr. Mehta also, who is a very senior person, and he's my alma mater also. I used to interact with him, and I had joined the training school long back. And I'm very happy to see him again here. I want to thank him also for writing a letter to me about this talk. And once again, thanks to Indian Nuclear Society for inviting me to share some of the activity which is being done at nuclear fuel complex. I'll not be able to touch definitely all the aspects, whatever is going on here, as here number of products, if you see, is very large, and the activities are also immense. So I'm going to give us some kind of an overview, and especially some of the new things which has happened in recent times. I'm going to share the talk. Okay, as the topic has been told, I'm going to talk about some of the development which has happened, and the new thing has happened. And this okay. So just little bit background. Of course, everybody knows that how the nuclear fuel complex has come up. This Dr. Vikram Sarabhai and Dr. Brahm Prakash, they were the two pioneers who really saw the nuclear fuel complex getting set up for producing the nuclear fuel. And in fact, today I was shared a sad news that the first project engineer, Sri S.C. Kataria, who was the first project engineer for nuclear fuel complex, passed away last week only. And he had been associated from the beginning regarding this particular project. And after that, we all know that Mr. Kundal Rao was the first chief executive of the nuclear fuel complex, and he was instrumental in shaping the nuclear fuel complex what we see today because of his immense contribution. And we all know that NFC came up from basically FD is called the mother of the NFC, where most of the technologies were developed either in atomic fuel division or in the modular lab materials group, and also the chemical engineering group. And all the technologies were developed there and brought here and then taken up to the industrial scale. Recently, we are now completing 50 years, and this just shows that we have Mr. Homi, Dr. Homi Bhabha bus we inaugurated on the view of 50th year of NFC, and we are very happy that Chairman and Director BRC could visit both at that time. This just shows that the long journey of 50 years, and I'm going to show some of the achievements in these years. Looking at the total domain of activity which nuclear fuel complex is involved, one of the major, of course, mandate is to produce the fuel, mainly for the PHWR, BWR, and also we are giving the structure material for FBTR and PFBR. In addition to that, NFC is known for making seamless tube and all the zirconium alloy structure materials for the nuclear in-core reactor material. So this includes coolant tube, pressure tube, Calandria Tube, Reactivity Mechanism. Everything is manufactured here, Garter Springs, and all those material, and supplied to the total requirement of nuclear power program. Additionally, we are making a non-zirconium based various seamless tube, which are finding application in many of our department as well as in defense and space applications. Recently, we have started making steam generator tubes also for the nuclear power reactor. We had made earlier also, but now it is almost 100% starting from the raw material. This SG tube set is being manufactured at NFC. As was said that we are committed to the mandate of the nuclear power program of Department of Atomic Energy. And we are having now a very robust PHWR program in which nearly 16 numbers of 700 megawatt PHWRs are going to be added up. And to meet the requirement of these 16 numbers of 700 megawatt reactor, one is already critical. We have to manufacture additional quantity of 2,000 metric ton of fuel every year. And we also have to supply structure material, both the pressure tube and Calandria tube and other materials, which is nearly 2 to 3 reactors load every year. At the moment, we are making once in 3 to 4 years. And additionally, all the reactivity mechanism also we have to provide for at least 2 reactors every year, starting from next year. And also, we are very happy to tell that the department has shown confidence on us, and they have given the total order for the fleet mode of reactors, 40 sets of SG tubes, and NFC is going to supply in next 4 to 5 years the 40 sets of this SG tube. Now, to meet this requirement, if you see how much we have to increase our capacity or deliverables. If you look at that, the way reactors will be coming up as per the NPCI plan, all these reactors will be coming up by 2031-32. Assuming the delivery, whatever has been envisaged, we in this graph it shows how the fuel requirement will increase, and we can see starting from 1,000 at the moment, we have to go to the level of nearly 3,000 metric ton. So that means we have to increase the capacity by 31-32 by another 2,000 metric tons, and the requirement at different timeline is mentioned here in this graph. Similarly, we have the requirement for the structure material which I mentioned here. It is shown in again in the diagram, and you can see that the requirement is used is nearly 2 sets of the pressure tube and Calandria tube we have to provide every year. And as I mentioned that at the moment we have a capacity to provide once in 2 years or 3 years. So this also has to be met. Reactivity mechanism requirement is also mentioned here. Just to tell about some viewers who may not be very familiar with the production activity, how these fuel bundles are made and what are the processes are involved. So you see, what we call is that NFC follows the philosophy of ore to core, means we start from the ore material and then final product we make it, and we make the final bundle. In fact, this is the only center in whole world where both zirconium and uranium oxide both are processed together, and this is in that way is a unique facility. So every components which are required to make a fuel bundle is produced in single campus. And
okay, Dinesh, can you use a pointer, please? There is some request by people.
Okay.
If it is possible.
Pardon?
If it is possible, can you use a pointer?
Okay. Arrow I'm using, is it okay?
No, yeah. Now it is.
Okay, fine. So, like I said that we produce all the materials in one campus. It involves intense chemical engineering activities, metallurgical engineering activities, mechanical engineering activities. All engineering branches are utilized to produce the products. For example, to make the UO2 powder, we have a 10-unit operations. Starting from the MDO, if you have to convert it to powder, it involves 10 stages of the operations. Similarly, to convert this powder into pellet, another 6-unit operations are there. I have not mentioned all the units because they are quite elaborate. And also, to make the component, zirconium component, we have to start from the zircon sand, and to convert it to zirconium oxide powder, it involves 10-unit operations. Similarly, to convert to sponge, another 5-unit operations are required, and then to convert into the various components, you can see that there are again huge number of cold and hot deformation as well as heat treatments are required before we get these components, and all these components in pellet then are joined together to get this bundle. Just the same thing is shown in few of the stages, like zircon sand getting converted to zirconium oxide powder, then sponge, then finally consolidated to ingot, and then this ingot is used to make the blanks by extrusion, and then using the some cold deformation unique process that is pilgering, very unique to zirconium tubing because of a specific texture requirement. This is used here, and then other straightening and other methods are used And finally, we produce various kind of tubes with the desired microstructure, texture, and mechanical properties. So this, and similarly to make the pallet also, this is the MDU powder which is converted to zirconium oxide, and then pallet, and then it is assembled along with this component. Just to sensitize how intense involvement is there to make one bundle, you see, if we have to make 3,000 metric ton of a fuel of 37 element type of a PHWR bundle, one bundle has a weight of around 21.5 kg in terms of the fuel. And to make 3,000 metric ton, we have to make 1.4 lakh bundles. And each bundle requires nearly 1,200 numbers of pallets. That means 1.4 lakh bundle will require nearly 16.5 crore of pallets. Similarly, fuel tubes is 18.5 meter, which is equivalent to 37 numbers. And when we make a 1.4 lakh bundle, then it becomes 52 lakh or 2,600 kilometer approximately. Similarly, spaces pad will be more than 2 crore. Bearing pad will be more than 75 lakhs. End caps will be more than 1 crore. And end plates around 2.8 lakhs. Not only that, we have to make all these components, we have to also assemble them. To fabricate that, one bundle has nearly 622 numbers of weld joints. And for making 1.4 lakh bundle, you are going to have 8.71 crore. So many fabrication steps are there. And also, you know, it's a nuclear product, so it has performance has to be very reliable. And for that, we have to do 100% UT visual and dimensional inspection of each component at different stages of fabrication. And also we have to have sound weld joints for which we have to do 100% UT examination. So all these total operations to produce this bundle will be immense. So how do we achieve this goal? So there are 2-3 ways. Philosophy is one is that technology upgradations. So far, we had started from the 100 metric ton fuel. Today, we have a capacity to make 1,500 metric ton fuel in nuclear fuel complex Hyderabad alone. And that has been achieved through mainly through the technology upgradation, some automation, and also the capacity augmentation by having better machines or higher capacity machines. This is just showing the picture of some of these efforts. Just if we see how the journey had been from the inception of NFC in 1972, the first bundle was produced in 73, and the first 1 lakh bundle was produced in 94 after 21 years. And next 17 years, another 4 lakh bundle were produced. And from 5 lakh to 10 lakh bundles were produced in 7 years alone. You can see how that production has increased exponentially in nuclear fuel complex. Technology upgradation are immense, numerous, and I cannot mention all of them. Just to take the example like UO2 powder production, we had to increase the production almost 300%. And to achieve that, in all these unit operations of the UO2 production, how the capacity increase was done by the various technological advancement which are mentioned here in this column. So by modifying all this thing, it was possible to increase, for example, dissolution by 100%, slurry extraction by 100%. All these capacities will increase by improving the technology. We are making like zirconium sponge. Now, we normally in the world, each batch is around 500 to 600 kg. Now, we are the first in the country, in the world, where now 1,500 kg batch has been successfully demonstrated. And that has definitely improved possibility of increased productivity, better purity as well, and recovery. So these are already introduced at Kalpakkam, where we have another unit where we make zirconium sponge only, and that is where we are making this batch size. Similarly, to make a fuel tube, now one of the way to increase the productivity of the fuel tube is to improve the recovery, improve the quality, and these are the various things which affect the recovery. For example, the UT defects, dimensional accuracy, surface finish, and rejections. A variety of things has been introduced, which has made it possible to now nearly 93% tube recovery, which is one of the highest in the world. And this was possible because of the different kind of technology implementation has been done, process has been improved. This just shows that in different production how the total capacity has increased. For example, UOT, you can see that from 186 ton to now 1330 ton of uranium powder is being produced. Similarly, sponge from less than 50 tons to now, which is being produced 750 metric ton. And pallet production also has tremendously increased. Fuel tube also from 50,000, now we are producing nearly 3 lakhs to 3.5 lakhs tube per month. So all this has happened because of the effort of the technology upgradation. Another effort which we have done recently is the introduction of automation. And introduction of automation, if you see why we should put more effort. Fuel fabrication, involves large number of chemical, metallurgical, and mechanical processes. And we also have very large number of intricate components. Their numbers or quantity is very large. And we have to make a nuclear grade quality, and that requires intense inspection at every stage. And ultimate goal is the zero failure target, which requires reliability, reproducibility, and precision across production, inspection stages, and final product. So we have in few years recently we have done huge effort towards introducing the automation in the production processes. For example, in the UO2 production, we have introduced state-of-the-art fully PLC-based SCADA system, and also we have automated radioactive slurry transfer system. Various such kind of thing has been introduced, and like introducing SCADA operation, it has improved the reliability in the process, and safety interlocks are better, and repeatability and reproducibility has been extremely good, and it has improved productivity. And if you look at the total effort of the automation in this UO2 production plant, the quality is nearly now 99% okay. We are hardly rejecting a single lot, and this variability in the process in terms of the quality is reduced by 20%. We have also reduced 40% in the man shift requirement. One of the major improvement is in the average air activity by 55%. This is nearly, we have reduced it to the half the level, and conversion cost because of all this effort has been improved by 15%. This is one of the highest recovery reported for UO2 production. Since we are going to, in the pallet manufacturing is basically UO2 powder which is to be handled, and we know that is a radioactive, and its exposure to our workers should be reduced to the maximum, and that's why maximum effort was put in the automation part here. For example, 3D UO2 granule blending unit, blending and granular transfer system, rotary compaction press has been introduced, automated green density measurement system has been introduced, automated green pallet charging system has also been brought in, and automated sintered pallet discharging system. All these systems have, I want to say here that most of this automation work has been done in-house, taking the help from the vendor from Indian industry. This conceptualization and the design part has been done in-house, and then it was fabricated in the Indian industry, and all that has been put in the place. And because of all this, a lot of improvement has happened. For example, for the rotary compaction press alone, if you see, the density variation in green pallet has reduced by 50%. This is a huge improvement. Similarly, the productivity has doubled because of introduction of compaction press. Various efforts of automation. Overall, if you look at it, again, it has made a huge impact. For example, quality has improved by 67% to 87%. This is again one of the highest or the best quality in the world. And this has saved nearly 1.16 crore pallets to be getting recycled. Similarly, variability has reduced by 3%. Productivity has increased by 30%. Handling defects, which are very common, has also been reduced by 3%. And again, as I said, that the radiological improvement has happened considerably, with the average air activity by 15%. To fabricate these bundles, we again our engineers have developed various machines. One of them is automated appendage welding. integrated end cap welding and machining unit, automated end plate welding machine. As I had said that more than 8 crore welding has to be performed. So it has to be in automated mode and reproducible and reliable manner only it should be done. So the automation has been given a lot of importance in this area of operation. And all that has resulted again in a consistent and very large manner. For example, bundle recovery is nearly 99%. Today, we take pride in telling that not even one bundle is rejected in 1 month. We used to have reworking in the bundle. We have stopped the reworking in the bundle. If any bundle shows any kind of defect, is rejected. So our, throughout the year, it may be only 8 to 10 bundle which is getting rejected. At the site also nearly 0% rejection is there. So this has improved considerably recovery because of these efforts. And other advantages has happened like improvement in man safe, improvement in productivity, improvement in machine availability. And of course, all that automation has helped in reducing the operator's fatigue, and then better performance is obtained because of that. We also had a lot of interaction with other agencies to introduce other automation for handling this radioactive material. For example, we have developed AGV, automated guided vehicle, in collaboration with BRC to transfer boards of uranium oxide pallets. We also developed this centerless grinding machine, automatic pallet stacking, automatic pallet loading machines. All these operations are now 100% automated, and we are hardly having any operation which are manually done. As I said that we have to do inspection also very intensely. So many operations are there, so many components are made. So to ensure their reliability, we have to have a very good inspection system also. And some of them are listed here, like automatic sintered pallet density measurement has been used. Automated UD for end cap welded elements. Now we are, because of this, which is in line with the welding operation, so we are able to do 100% element testing. Earlier we used to do 10 to 20%. Similarly, we have now got integrated helium leak testing and UD system for fuel elements. This also has helped us in improving the quality. And of course, we had earlier automatic fuel bundle inspection system, but we have drastically improved in terms of introducing helium backfilling, all the dimension measurement, everything is now being done in an automated manner. All this effort in fuel fabrication has led to drastic improvement in the radiological safety. 60% reduction in average air activity has been achieved in the last 3 years, which has been highly appreciated by ARP and other regulatory agencies. We have reduced 40% reduction in total occupational dose because of all this effort which we have carried out. And more than 99.8% samples which we are collecting are below DAC level, which used to be much higher earlier. And we are able to have very good result because of all these various operations being made automated and good quality process. I want to mention about the components also. These components, as I said, that appendage welded welding and all that components, bearing pad, spacer pad, and cap, they are in crores and in lakhs. And they to do their inspection, it is nearly very difficult to have a reliable way. And that's why in collaboration with RRCAT Indore, we had been able to develop vision-based inspection system for appendages, vision-based inspection system for end caps, and vision-based inspection system for end plates. All these has been introduced last 2 years, and we have a series of these machines, and we are able to do 100% inspection, which was earlier being done manually, and only certain percentage inspections were being carried out. For example, if I give example of this end plate, you can see that there are 11 dimensions which has to be measured, and it was being done by the vernier calipers. Now, vision-based system does it in 30 seconds, and it records all the dimension, and also you have storage of the information, and also it does the rejection and acceptance, everything through the computer. So it is much more reliable, and all this has resulted in high degree of accuracy, reliable and reproducible. 26 QC operation has been automated so far, and 30 times increase in inspection capacity. And using this method, we have done already more than 2.5 lakh and plate measurements, and all are very accurate. We also introduced this automation in production of various other materials, especially the static tubes. We have introduced roller furnace, induction furnace, and continuous furnace. All these furnaces are very special type of furnaces, and that has helped us in improving the recovery part. I will be mentioning in the later in the presentation. Similarly, material handling, which is very important for the sake of improving productivity, also safety also. Here you can see that series of equipment where the material handling has been made automated and machine based, and this has resulted in 30% increase in process cycle and 50% increase in productivity, and definitely huge increase in the safety and definitely reduction in operator fatigue. This just shows the summary of the automation, like how the productivity improvement has happened. As I said, in fuel, better than 85% recovery, specialty better than 90%, which are the one of the best in the world. High productivity, 30 to 50% across all workstations. Massive requirement is reduced by 20 to 40%. Economy and fuel performance, like for example, overtime compensation, we have reduced by 4 times in last years. That is almost nearly 60 crore per year. And fuel bundle performance, if you see fuel reliability indicator index, this has been found to be reduced from 0.37 to 0.037 in some of the reactor. This is the lowest observed in any reactor in the world for the PHWR. And we have shown in some of the reactors, this value is achieved. And that shows that our bundles are of the quality. If in ideal condition, they will behave as one of the best bundles, which is being used like anywhere in the world. Improved safety, we have no reportable incident in last 2 years, and definitely, as I mentioned, recent radiological improvement has happened. All this has led to various awards, including the series of industrial safety awards, like we never used to get in Hyderabad. Now we are getting award for Hyderabad also in last 2 years. We got the safety awards and other Swachhata award for the better practices. Third thing which I mentioned about the augmentation of the capacity, and that is the quota. One fuel plant is coming up the quota, which is a greenfield project, and this is originally it was a 2,400 crore project. Now its revised cost is 4,256 crore, and design capacity at the moment is 500 ton. That is fueling to the 700 megawatt reactors, but there is a possibility to enhance it to 2,000 metric ton as well. And I would like to show some simple, a small video film of both my this automation as well as this quota project. I'm going to just switch over from here to video film. Just these are just 2 to 3 minute video film. मैं पहले इसको क्लोज करना, क्लोज कर दो इसको क्लोज करना, दूसरा फिल्म अदर वन दिस वन. This is a film about the automation. Okay. We can go to the next slide, which shows some of the progress which has been made at the Rautbhata quota for the nuclear fuel fabrication plant. Please again 2-3 minutes only. Sure. Presentation. So, okay, just after this film, because now Kota project is definitely taking a shape, I wanted to share some of the progress which has happened. And this is a really a green field project, and last 2.5 years, we have made a very good progress, even though COVID pandemic was around, but still nearly 2,000 people were working at the site, and we have made very good progress. And these are some of the installation which we were showing in the movie. Now coming to the last section of my talk, I just wanted to mention that see, NFC is making fuel. That is one of the things, but as we all know that NFC also has expertise in making the seamless tube, and we make the seamless tube of all shapes, of all the dimensions, starting from few millimeter to very large size. Nowadays, we have made recently even 500 millimeter dia tubes also, seamless tube also with the new technology. So that expertise is not available in the country. The kind of expertise it is available with us, and we have made with all the kind of material. You name anything from all titanium alloys, zirconium alloys to even special alloys like super alloys and other alloys which are being used in strategic as well as this aerospace industries. So some of them which I want to mention here is like, for example, Titan 24. This is one of the very specialist tube which is normally imported, and first time it was developed, and it has a lot of challenging thing. It is a very complex material which is very typical of very high work hardening rate is there, and controlling texture is very difficult, and surface crack generation happens because of our hardening, and it has to meet a flattening test which is very challenging. So with the BRC collaboration and NFC collaboration, the full metallurgical and deformation studies were carried out, and today we have developed the expertise where we are able to supply all dimensions of the tube. Variety of dimensions are being manufactured here, and we have got a very novel fabrication route, and because of that the productivity has increased twofold, and our recovery also has improved threefold, and now total requirement which requires this country we are able to manufacture. We have improved our capacity so much, and with the quality, in fact we are giving 100% recovery, whereas the imported one never gave more than 80%, and our customers are very happy about it. Okay. Yeah. So another material which is a very novel material is a nickel-based alloy, and this material was originally used for reprocessing plant because of very high level of corrosion resistance, and in fact it has a very good resistance for the irradiation also. It was taken up as a project long back in 2013. And over the time, now we have developed very good expertise. You can see how we have gone about producing this tube. Today, we have mastered the technology so well that we can produce even up to 9,000 to 10,000 tubes per year, which is a huge number. And this is a very special tube. Wall thickness is 0.25 mm. Or less than that, and size is also 4 mm to 6 mm. That is the kind of diameter, and we are giving a material with no reworking allowed, with 100% UT and ECT okay strategy, and the surface also has to be extremely superior. So we are able to make this And thanks to, because it requires a very peculiar type of heat treatment where it has to be soaked within 1 minute and quenched from 1150 degrees centigrade to the room temperature. And all this has to be done in a gas environment. And we have developed, again with the collaboration with BRC, 3 types of furnaces, where this is a continuous type of furnace. Such kind of furnace now is not available in India. It's very unique. We are able to produce these tubes in-house and with a very high recovery. We are showing that before we had technology not very mature. Today it has matured and we are making the tube with more than 90% type of recovery. And that has made the price of these tubes much, much lower. And this has helped us in producing the tube in-house. And now we can meet total requirement of the country again about this material. Recently, we have also supplied Inconel the 69060 tubes, which is a requirement of NRB. Again, this NRB was importing so far about this material. And we have made 13 types of tube with the different dimensions and thickness. And they have met all the requirements. Again, we did all the in-house metallurgical and other studies to get a proper flow sheet so that all the requirements of the tubes are met. This has been successfully supplied to NRB, and all future requirement now will be met by NFC. We also deal with the various special grade steels. One of them, like I mentioned about the steam generator tube, which is alloy 800. This tube now is raw material is made by the Midhani, and then it is processed at NFC. And we are now producing with such a high quality that nearly 95% recovery, which is totally unheard in this particular sector. This is a 25-meter tube with more than 100 types of these U-bands. All these are showing nearly 100% UT recovery and ECT recovery, which is extremely good for the standard of such kind of tube. And other kind of tubes which we are making for quite some time is the D9 tube, which is used for the PFBR fuel, and also 304L, 321, and some special grade for the PFBR. These are being done on a regular manner. There are a whole big list of such kind of tubes. I'm mentioning only which are large in quantity, which we are manufacturing. Alloy 617, I want to mention here because of the unique alloy, which is a structure material for the ultra supercritical thermal reactor. And in collaboration with the IGCAR, this material was processed here, and also Midhani was involved in this. And successfully, we have made the tube and delivered it after a lot of studies and a lot of development activity, which was involved both from the IGCAR and NFC, and we have successfully developed it and delivered it to the customer. These are some of the other product for the defense and aerospace. I'm not going to read out, but they all are in use and being successful in their application. So in the end, which I want to say is that, which is again, this is the dialogue of NFC means never fails in commitment. This slogan was given by Dr. Balamurthy, our respected chief executive, former chief executive. He was instrumental in making many projects successful here, especially the development projects. And he had been always saying that NFC, whatever the project it takes, it always delivers it successfully. And we have met all the projects, whatever has been given. And as I mentioned, even during the COVID time last 2 years, not a single supply of the fuel or any structured material was hampered because of the COVID. We had been working continuously all throughout the time. Only 15 days our plant was closed, and our colleagues had been extremely supportive, and we could meet all the commitments even during the very severe lockdown when the supply of the fuel was really very challenging through all the curfews and everything. But NFC had done it, and it was well appreciated by the department and NPCI. So this is all I wanted to say about NFC, as I said earlier, I cannot touch upon everything, but some of the things which I felt may be interesting to the general community of Indian Nuclear Society, I have tried to speak about them. I'm available here for any question or any discussion anybody wants. Thank you very much.
Thank you very much, Dr. Srivastava. And we will go for the question answer session, because Dr. Srivastava has given us the information which makes us proud, not only as a DA family, but as a common man also, because whatever improvements, whatever the progress is happening, whether it is space, whether it is nuclear, whether it is defense, ultimate benefit is for the common man, because all the products which come to us, new products, they come from such researchers only. Similarly, the quality, what he was mentioning about the fuel tubes, the bundles, etc., has got a direct impact on the common man, because it's if the quality is good, the radiological consequences to the common man on the power plant or any other processing facilities are much lower. So we are all proud, sir, because of all the achievements you have really achieved in a short time, and that's great for us. So I would invite the questions for Dr. Srivastava from the audience.
Sir, Avinash Gaikwad here. Dharnesh sir, good evening.
Good evening. Yeah, you can proceed.
The presentation by Dinesh ji was very good. It brought out very clearly. First of all, congratulations. You have brought out the achievements in the recent past. And we know your technical expertise, but your management skills and administration also you have demonstrated. So I'll quickly go for two questions. First one is like nowadays it is related to technical things only, and the second one is also related to this only. Accident tolerant fuel, that nationally and internationally there are a lot of developments, and there are two types. One is the with coating and another is altogether new clad material. So I need your comments like what in this area. And quickly the second one is about this slightly positive void coefficient. So are we doing something on that with the pellets if we have burnable poison? So thank you very much. These are the two questions.
Okay. So as you had said that, my background is more from BRC. I've spent more than 30 years in BRC, 33 years in BRC, and only 4 years in Hyderabad. So let me tell you that NFC normally do not initiate a development project. NFC normally, in development projects like is initiated by BRC or IGCAR or RRCAT, and they are giving the engineering expertise to produce it in an industrial environment. So that is the in general base. And so development may be like, for example, in fuel fabrication, we may be doing some development activity in terms of the welding process, welding equipment and all that. But technologically, which is required for the program of the nuclear program, and normally it comes from the BRC or IGCAR. So I'm aware about both these accident tolerant clads, which are very important to do that. We'll be very happy to be associated if BRC takes a lead in that, and we can form a task force and we can do all the processing part, fabrication part, or developing the process part. And we need support in terms of metallurgical and other things for the characterization and all that. So it has to be a joint program. This is my feeling. This is the first thing. And the second thing you mentioned about that also, this side also, we do not work on the designing part of the fuel and all that. It's normally we have been given a specification by NPCL, and we try to manufacture this fuel as per the specification of NPCL. So this also, I just want to intimate that we are not involved in such kind of development activity. It's mostly like if we are making a fuel, we want to make in a better way, with a better quality, with a better process. That's where the development activity is taken by the NFC.
Yes. Thank you very much. So it is more of a research, and then it will come to NFC ultimately.
Yeah, means together we can work. Means when some development has happened, the manufacturing can be done here, and then further analysis can be done. And like that, going coming and forth. Like that, we have developed like a new this fabrication route for our coolant tube. We developed a fabrication route for the heat treated pressure tube, and now we are going to introduce a forging route for making all the product for the zirconium. So such kind of things, work is continuously going on in collaboration with other, mainly the BRC for the zirconium alloy product, and for the other BTR related and PFBR related, we are doing with IGCA, for example, making ODS tubes here, or making this which I mentioned about D9 tube, such kind of thing, and in around 617, all that has been done here, but the collaboration was with this IGCA.
Fine. Thank you very much.
Thank you. Any other
Srivastava,
question?
this is Manchanda here. Srivastava,
Good evening, sir.
good evening.
Nice
How
to
are
meet
you, sir?
I'm fine, sir.
I've seen you after an age, actually.
Yeah.
So,
Very long days, sir.
see, I, of course, want to congratulate you for doing wonderful job and setting up the new facility at Kota. So, I think it is going to add great value to our whole program. I have a small questions, actually, they are a general type. As far as the Bhavani fuel is concerned, as you know, it is fabricated at A3F in Tarapur.
Right.
But some of the components, particularly I think even the tubes and all that, they must be manufactured at your end, actually. So, unlike the UO2 fuel, which is sent to PHWR, everything is assembled at your end and then you ship it. So does it pose an additional problem, that is the fuel pellets coming from the one end and then the tubes and other assemblies coming from your end at the Bhavani site, actually? Does it pose any additional challenges, actually? So that is my first question. My second question is, see, you have now taken up very challenging jobs of new materials, special materials. So molten salt breeder reactor, which is using the mixed fluorides of thorium, uranium, lithium, beryllium. So whether some, container or some materials have been used, you got the order, and whether they were tested at some of the facilities which are supplied by NFC. So these are two small questions.
Okay. Regarding the first question, you see, of course, as you said, PFBR, nearly 16 type of assemblies are made, and everything is made here. But for the fuel, we make all the components which are required for making the fuel pin. So we supply the tube, spring, and all that, and cap and everything, which goes to the AFFF, and they make a fuel pin. Okay, so this fuel pin is made, which is perfectly welded there, both the side. It is totally safe. Nothing is coming out of that. So where these fuel pins are then loaded into the magazine, and this magazine is shifted to the Kalpakkam side, and there we have our own assembly plant. Fully automated assembly plant is there, and there then these pins are made into a cluster as per the design. That part is done by us. So that fabrication part, from the pins to the fuel assembly is done by us. So it is not a very difficult thing, because we are giving a structural component there, and they fill the pallets, then weld the ends, and now they secure it very nicely. So then no radioactive material or the radiation will be coming out, and then it is put in a safe magazine cassettes which are there, and then brought to the site, and at site we do the assembly, because the assembly has to be kept immediately into the vault, and that is done there.
So these pellets are brought to Hyderabad first?
No. We are only making metallic components like metallic tube, metallic cap, and the spring which is to be loaded. Fuel pellet is made at AFFF, loaded there. This material goes to the Tarapur.
Okay.
In the pin they are loaded and the welded. Okay. And regarding the second part, this molten salt breeder reactor, to my knowledge, see, some of the candidate material we all know, like Hexalai and some of the special niobium based and nickel based alloys are there. So again, as I said in the previous question, that we have normally we get request from BRC or somebody who wants to use that. And NFC does not have mostly a big facility for melting the alloys. We have a facility to process the alloy. So what we do is sometimes we collaborate with Midhani, which has a very excellent melting facility. We also have a small melting facility, so we do it. So what I understand that hex alloy has been already made and supplied to BRC, and BRC is doing the research on that as a looking at the compatibility of that material with all these chlorides and fluorides. So this research is going on. As of now, this is the total update I have.
Thank you, Doctor. Mr. Manish Jaroli has 2 questions. Can you ask them? Mr. Manish Jaroli.
Yes, sir. Yes, sir.
Yeah, please.
Manish Jaroli from reprocessing plant of Tarapur. My first question was related to 3D printing. Whether any scope is there for 3D printing, and second question was regarding niobium, that superconductor, whether NFC is manufacturing that niobium. Thank you, sir.
Okay, thank you. So 3D printing definitely is everybody interested, and it has an enormous application. And depending upon the what kind of components we want to make, for example, whether you want to make a alloy and then a component, or you want to just make the prototypes, it depends what is your end application, and accordingly you will do it. I have been involved in this process at BRC also. There is a facility at BRC, and RRCAT has developed a much better facility where they are doing the metallic component 3D printing. See, the other 3D printings are very easy, but the making a metallic component to the net set is very challenging. So I think RRCAT is already doing that. NFC has not taken any initiative in that. As I told you that NFC will take up if there is any application comes. If that is application requires the 3D machine manufacturing, then probably we'll take up that project. But so far, no requirement has been given to NFC regarding making this prototype. Basically, it's meant for the low volume and more complex seat manufacturing. So far we have not got such kind of thing. So no initiative has been taken at NFC. And regarding the niobium manufacturing, yes, we are involved very much, and we have been using electron beam melting facility to improve the purity. And the last 4 or 5 years, we had supplied a lot of material to RRCAT, and they are doing the characterization. And we have reached to the level of less than 100. The triple R value we have achieved less than 100 also. So we are making good progress, and with PRC collaboration, we have made a very big, electron melting facility. So it is possible now to produce in terms of several kgs batch very soon, and that will be acceptable for the application of superconductivity cavity and other things. That we are very much involved in that.
Yeah. Thank you, Dr. Srivastava. Mr. Bhanumurthy, you have got 2 questions. Can you pose them?
Hello, Dr. Srivastava, this is Bhanumurthy.
Yes, nice to hear you.
Yeah, nice talking to you after a very long time.
Yes.
More than maybe 4 years.
Yes, almost 4 years.
First of all, the automation that has been observed, that has been implemented, has been really wonderful to see those videos. It speaks quite volume of the work that has been achieved. I have 2 small questions in which I was involved in NFC in the beginning. One is what is the current status of this oxide dispersion strength steels, which we're doing with IGCAR, and also some characterization work done at Material Science Division. The fusion reactor process is still going on. And second thing is that what is the extent of the enrichment that is being planned to get a higher burn up in 700 megawatt electric reactor? That is also being really, I heard a couple of times presentation be made by some of the seniors at Department of Atomic Energy. The first question is the current status of the RDS.
Okay.
Is it continuing?
I've got the questions. I've got the question. So this current status is like that. We had made high chromium alloy ODS, and later on it was observed that it is not good with many properties. And then IGCA was working on the low chromium, I think the 9 chromium, 12 chromium type ODS, and they are still interested. And we have now full technology. And as and when they want us to process with a new composition, we are able to do it, because as you know, ARCI does the canning part and powder metallurgy part of mixing this ODS material, that is Yttria and other material. So that part is being done there, and the canned material is brought to the NFC, and we do the extrusion. Recently, we had done one more batch, and that has been taken by IGCA to do the further research on that. So this was going on, and IGCA will be better person to tell you about the status in terms of implementation, because so far we are making D9 only, and the D9 is going on regularly. And this is the status. And regarding the second about the enriched uranium oxide for the PHWR reactor, yes, these are the talk going on, and you may be aware that Canadian are already talking about their next generation reactor with the enriched fuel. And this enriched fuel, the concept is that there are two concepts. One is that many times this PWR material fuel which comes out is still having quite a bit of uranium, enriched uranium, which can be used as a starting material, means feed material for the PHWR. So that is one of the concept of using slightly higher enriched 1 to 1.5% type of thing. And also we can have enriched fuel and then use it. So far, as I understand, NPSCL has not done any experiment on that. No bundles have been made with the enriched fuel so far. Which of my knowledge. So NFC will make it as and when the requirement will be given by NPCL, and that is the time we'll make this experimental enriched bundle for any experiments to be done in the reactor.
Thank you, Doctor. I see Anushka Sarkar having 2 questions. Will you like to pose it?
Hello, sir. Sorry, my daughter's name came there. Actually, sir, I just wanted to know about the main goal of the quota plant. It is to increase the total output, or to particularly support any stage of Indian nuclear program.
Okay, so this is basically a fuel fabrication plant. Unlike nuclear fuel complex, which has a mandate for all the structure material also to be made, which is the in-core structure material, and also the requirement of other department of atomic energy, as well as space and defense also. So here in Kota, we are going to make absolutely only PHWR fuel at the moment. And this is having a capacity of 500 metric ton, which can support 4 700 megawatt reactor, which can be easily upgraded to 1000 and 2000. That is the way it has been planned. So this will be supporting to the PHWR 700 megawatt reactor. As of now, that is the plan. So this will be because the capacity at Hyderabad will not be enough to meet the total requirement of the PHWRs if all the 16 PHWRs are coming. So up to 4 probably we can support. Beyond that, we have to have additional fabrication facility.
Sir, I have one more question. Just to know that since there are so many of foreign reactors are coming, so preparation of their fuel in future will be done in the safeguarded facility. For that, some new facility need to be developed, or the present facility with a time constraint safeguarding will be enough?
See, we are already processing safeguarded fuel for our reactors which are under IAE safeguard. So those fuels are being manufactured here for PHWR. We have a 2 fabrication location, which makes one for Indian safeguarded and others IAE safeguarded. And similarly, Kota also will have that. But these both are for PHWR fuel, and as well as BWR fuel is being made here. Regarding the now a lot of discussion is going on for BWR reactor. That BWR reactor, there is a department wants to source the fuel from the indigenize. They want to do the indigenization, and there's a committee which is having interaction with the Russian as well as Indian counterparts. NFC is very much involved in the whole process. That where and what kind of facility is required, what kind of support system is required. Everything has been worked out, and it is in discussion mode. So there is a possibility to do it. We cannot say which site and where it will be done. Those things will be more like a policy decision.
Yeah, thank you so much. Mr. R.K. Pant, would you like to pose your question? Mr. Pant? He has asked whether NFC is developing niobium, RRR greater than 300.
Yeah, this is RK Pan, sir. Good evening, sir.
Yes, good evening.
Yes, I want to know, sir, whether for superconductors, niobium requirement is RRR greater than 300. So are we able to generate at present?
Yeah, so as I answered somebody earlier also, that we are very much in this project, and we are doing a refinement process continuously. Around 100 we have already achieved. Better than 100, we are still working because there are certain impurities which we have to take out. There are, like RRCAT is interested in taking slightly inferior RRR value also for doing the various other activity that anyway we are going to supply. So we are very much involved, and we hope to improve it because we have got now correct these equipments and processes. So it should be possible. Only thing is very time consuming, and IBM is highly material which picks up the things, impurities from the environment. And since NFC is involved in variety of the things, this is one of the problems. You should have very, very safe and pure environment where you should process this material. Then we can have much better. So this all effort is going on, and we have a lot of interaction with both BRC as well as this RRCAT. In fact, we have a requirement given by the VVCC also. We are going to supply the material to them also.
Okay, thank you, sir.
Thank you. Thank you so much. Dr. Shyam Srivastava, can you put your question?
Yeah, thank you very much. And I'm sorry, I'm not a technical person, so I will be asking maybe some silly questions in that. I was just thinking that before you have really augmented all these processes and coming with a newer material also, we were earlier importing all these materials or we were also manufacturing, and now are we in position to really export them? So I mean, just to think of one way. And another very, maybe a very basic, a silly question also, nowadays, a lot of people do talk about artificial intelligence. So are we really going ahead and thinking about that artificial intelligence, mainly for quality assurance of material like that?
Yeah, I think you have asked extremely relevant question. They are not at all silly. And I just want to say that whatever the effort it is being done here, one is like whatever the current product is there, how we can make a better quality. This is one effort to improve the quality, and second is how to improve the productivity so that we can reduce the cost. So these are the like a continuous process. Then there are certain tubes which I talked about, development of the tubes, special tubes of the special material. They all are 100% import substitute. And in fact, we have stopped importing some of them already, and it is being supplied by NFC. And this selling it internationally, like for example, SG tube, whatever we are making now for NPCIL, I'm sure that earlier it was coming from Belnux and Sandvik. Our tubes are no less than these tubes, and we will be able to compete with them in anywhere else, because our cost of production will be definitely much lower. So this is being discussed at the department also. Some of these tubes we can definitely, seamless tubes we can manufacture and export. So fuel has many other complicated issues in terms of the exporting, but tubes are very easy to do that. And in fact, we can make any variety of titanium-based alloys, which are going to be one of the material required in huge quantity in the country.
And a short question about artificial intelligence.
Yes, sorry, I meant artificial intelligence. Yes, you are very right. We are interacting with DRHR, BRC, and some of this vision-based system we want to use for assessing the quality of weld or assessing the surface quality. All these things where artificial intelligence is going to be utilized. We have not got a system so far, but almost matured stage it has reached. So at least first system we'll be seeing very soon, where the artificial intelligence based software will be used to do the quality assurance, and that is very much in development stage, and it should come.
That's
Thank you
great.
very much, and wonderful presentation.
Yeah, that's great, because we are in line with the current times using AI.
Yeah.
Okay, there is one Mr. Vijay who says that there is one question. You can pose your question, please.
Yeah, good evening, sir. I'm Vijay Chaudhary here from NPCL.
Yes.
So I'm having one small question, like what we talk about the automation at our manufacturing end, whatever the NFC is doing. Yeah. Now, if we want to consider some changes, say based upon some aging parameters and all this thing, and we want to enhance our safety margins. So yeah, how we are prepared to accommodate these changes in the automation line or in the production line? So what is our preparedness to accommodate such changes?
Okay. See, in automated plant, it is always much easier to introduce, because we are producing at a very narrow range of product, with a very narrow range of specification of the product. Now, if you want to further, squeeze in and all that, definitely we have to modify the equipment to see that it can meet those targets. But this has to be done first in the laboratory scale or in the prototype scale, and then establish it, then bring it to the realistic industrial scale. So it is very much possible. There is no problem. In fact, all the equipment which we are putting, there is always a newer version of the equipment. So newer version means we have better technology and better methods, and that helps us giving a better performance in terms of both specification and as well as reproducibility also. So this is happening. For example, end cap welding machine and all that, we have in NFC, it is being made from last 40 years. But if you see the first machine to the current machine, there is a huge improvement. And all are integrated operation now. Earlier, there used to be different operation, and we used to integrate them. So this is a continuous process, and NFC, because of blessing this guy, that denial regime was there. So everything was most of the equipments were developed in house. So they understand that how to develop this equipment. None of these equipments are part out items. So we have advantage that we can always modify it. If it is a part out item, then definitely you cannot do much changes.
Yeah, maybe not the bulk of the things need to be changed or for the standard design, but maybe some limited number of the things for some specific reactors we want to accommodate. So
yeah, very much. See, these are possible.
Okay, fine. Thank you, sir. Thank you very much.
Thank you. Any other question? Because all the reported questions are over. So if somebody wants to ask a question, we can have a question or two.
Yeah, Dr. Dinesh, I'm Chandrakar speaking.
Yes, Chandrakar.
Yeah, I think your lecture was very interesting and informative. And my question is regarding this manpower requirement. How do you plan the availability of skilled manpower for future requirement? And in terms of, you will be incorporating new technologies like artificial intelligence and vision-based inspection system. So many new things here are in the line. So how do you plan to maintain the availability of manpower in future? Is there any specific effort in this direction?
So you see, when NFC was producing 200 metric ton of fuel and very few other items, and they were producing like one reactor load of coolant in 3-4 years. They had 4,000 workers here, which were involved in producing that. Today it is nearly 3,000 only, and instead of 100 to 100 ton, we are producing 1,200, 1,300, 1,400 ton per year. We are also now producing variety of other products which were not produced earlier. All this has happened possible because of technology. and also this automation and this kind of thing. And today we have also a little bit support of outsourced manpower. Skilled outsourced manpower is also available. So we take help wherever is possible. We strategic material is there, or which is non-Zirconium material is there. We also take the help of the industry, because our supporting industries are also developing. So it is a combination of all the three. We are able to manage that, and definitely manpower per ton of fuel will continue to decrease in the future.
Yeah. Okay. Thank you. Thank you, Doctor.
Thank you, sir. Thank you very much. I think we are coming to the end of the question answer session. I will just pose one question in my line of work.
Yes.
As there is as you mentioned about air quality, as well as you mentioned about the personal dose, what are the safety assessment techniques you provide or you use for doing these jobs?
So I'm not expert probably in this area. We have a few, which is a BRCs here. Means their people are here, and they do all the standard testing. Equipments are made available as per ARB guidelines. So I will say that I am more knowledgeable about the numbers. What is the number today and what is the number it has improved or not improved. But techniques and all that, probably my SPU colleagues can tell you more about that. Mr. Jha is involved on the RC. He is the in charge here, Kulkarni and all that. So probably I'll not be the right person to tell. But definitely, these numbers are because of their help, we are able to improve it, and their guidance only helping how we can reduce it, what we can do, and this.
Good. Anyway, the numbers do speak about the processes which are being followed. If the numbers are improving, obviously the processes are in the right direction. Yes. So I'm sure that there are proper processes are happening there. So thank you so much for your interaction with in question answer session, as well as a fantastic presentation which you did, making us all proud, as I said. And now I hand over the baton to Mr. Malhotra for a vote of thanks. Malhotra ji.
Yeah, good evening. Thank you, Mr. Dharne and Mr. Dinesh Srivastava. I will start with you. Oh my God, what a talk. Wonderful. See, during all my visits in my service period, I have visited NFC umpteen number of times, and I have always found, I always used to comment that NFC, I have always found a very, very happening place, very dynamic place. Whenever you go, people are simply excited to show you what they are doing. I mean, in any unit, it is like that, but I think there is some extra in NFC, and I think in a very similar manner, today you have taken us for a pleasant and very informative journey of NFC. At least for me, it was wonderful, because having retired 6 years back, naturally, I think my last visit to NFC was somewhere in 2014. After that, I have visited today. I really feel I have visited it today. So thank you very much for such a lucid talk and such a wonderful talk full of, the self-belief of the unit. I am not talking just of the speaker, of the unit on behalf of which you were speaking. So wonderful. And my congratulations also for that. And friends, we would like to thank the entire executive committee of INS for yet another fantastic webinar. And especially I would like to thank our president, Shri Mehta, for the continued guidance for arranging all these webinars. And then, of course, everything is happening because of the webinar subcommittee and its convener, Mr. Ramarao, and other members. I am really thankful to them that now the webinars, in fact, last more than a quarter, when Mr. Ramarao took over this activity, I think continuously the standard of our webinars is increasing, and of course, very consistently they are happening. So my compliments to the team. And then, of course, see, you have the speaker, you have the audience, though it is not predictable. I will talk about the audience also today. You have the topic, everything is there, but if the information does not reach the prospective audience, how will they be able to attend? So my special thanks, like in every episode, I tell, every webinar, I am thanking Dr. Shivjit Rajgopal from BARC and our own treasurer, Shri G.D. Mittal, who put tireless efforts in making the information, propagating the information about these webinars to a large number of people. And last but not the least, I want to thank the audience today who have hit a century. I think after a long time, they have hit a century. So I could see more than 100. I don't know. I mean, I am very happy. I don't know the reason, whether it is personal popularity of Dinesh, or is it popularity of NFC, or is it some local effect of Hyderabad? So, but I could see the total number exceeding 100 today. So thank you, each one of you. Thank you very much for because otherwise in between our numbers were, I think one of the webinars, our number was as low as 25. So thank you very much for that. And before I, of course, my vote of thanks is over, but every time I also announce about the next webinar. So I'm very happy to inform that our next webinar will be on 5th February, and it will be delivered by the Chief Executive of yet another industrial unit of EAE, and that is Mr. Jitendra Srivastava, Chief Executive of Heavy Water Board. The specific topic I have not received, but I can guess. I think he will be speaking about the developments and activities at Heavy Water Board and various heavy water plants. So I think I request all the 100 who have joined today to of course, I can't tell them keep joined till the next webinar, but please do come back in the next webinar also, and let us make it a habit in the INS webinars that we hit century whenever there is a webinar. Thank you very much. With that, signing off, and wish you a very good time ahead, and meet you on February 5. Thank you. Thank you. Thank you, one and all.
Thank you. Thank you very much.
Thank you, Srivastava. Thank you very much.
Thank you.
Thank you, sir. Thank you very much.
Okay, this you can.